In this screencast, we are going to do Unit 3, Part 1C, graphing horizontal and vertical linear inequalities. So linear inequalities in one variable can also be graphed in the coordinate plane. They take the form of horizontal and vertical lines. However, the process is identical to graphing oblique or slanted lines. So we are going to graph x is greater than 4. We're going to do it on a number line, and then we're going to do it on coordinate plane. So if you check out the number line here, this is what it's going to look like. So remember that symbol is x is greater than, so it's an open point, which you can see right here. And then we have our arrow going to the right because x is greater than 4. So what we're going to do for our coordinate plane is we are going to graph our line. It is vertical and it's dotted. So at 4, we're going to plot our point, and we're going to have a dotted line. Sorry, it's not very straight. Okay, so once we have that dotted line, we want to see which side we're going to shade. So in class, I had mentioned about the vertical lines are the only ones that don't have a top and a bottom part of the graph. They have a left and a right side. So as you look on the left side, those numbers are getting smaller, and on the right side, those numbers are getting bigger. So we want to use that to help us to see where we're going to shade. So since x is greater than 4, we're going to shade everything on this right side. In this next problem, we are going to look at doing application problems with linear inequalities. So in problem 5, a European hockey league, a player gets 2 points for a goal and 1 point for an assist. So suppose a player's contract stipulates that he receives a bonus if he gets more than 100 points. We're going to write a linear inequality that can represent the number of points and goals the players need to get a bonus. And then we're going to graph this. So we are told that x is going to be goals and y is going to be assists. So what we're going to do is we are going to write our inequality. So we know that the goal is x, and we know that each goal is 2 points. So we're going to start by saying, all right, we're going to take 2 times x, or 2 points per our goal, which is x. We're going to add in our assists. Each assist is 1 point, so we're going to add in 1 y, so it's 1 point per assist. And we want those points to be more than 100. So we're setting up the inequality. Again, we're taking 2 because that's our goal, the points for the goals, x is the goals, plus 1 because that's the points for the assists, and y represents assists, more than, well, that looks like something else, and then our 100. So from here, we are going to draw a line through our inequality, and we want to get that y by itself. So we're going to subtract 2x from both sides. So we are going to bring down our 1y, or just y, bring down our symbol, and now we have 100 minus 2x, or we can say negative 2x plus 100. I like to leave it in this format just because we're used to seeing the slope and the y-intercept. But like I said, you could rewrite it as y is greater than 100 minus 2x. These are saying the same exact thing. So looking at our inequality, we have our slope and we have our y-intercept. So on the graph, we are going to put our y-intercept point at 100, and then our slope is negative 2, so we're going to go down 2 over 1. So we're starting at 100, we're going to go down 2 blocks over 1, down 2 over 1. And the reason we can go down 2 over 1 is because these axes are counting by the same thing. They're counting by 20s, so even if we said down 20 over 10, it's still the same thing as down 2 over 1. So looking at our inequality, we have this symbol here, which is greater than. So this is going to be represented with a dashed or dotted line. So we're going to draw that. And then we need to decide which side we are shading. So we have the part that is above we have the part that's below. So looking at our inequality, we have y is greater than, so that's going to represent the part that's above. So everything up here would get shaded. For this problem, we have Jesus has $30 to spend on food for a class barbecue. Hot dogs cost 75 cents, including the bun, each, and burgers are $1.25, including bun and salad. We want to plot a graph that shows all combinations of hot dogs and burgers he could buy for the barbecue, spending less than $30. So this problem, we are not told our x and our y, so we're going to start with that. And I'm just going to say we're going to make x be our hot dogs, and we're going to make y be our burgers. That way we know when we're making our inequality which value we're talking about. So similar to the previous problem, we are going to take the cost. So we know that hot dogs are 75 cents. So we're going to take 0.75 times x, because we don't know how many hot dogs there are. We're going to add in our $1.25 y. Y is our burgers. Again, don't know the number, but know each one is $1.25. And he needs to spend less than $30. So the less than symbol, because we want his amount to be less than 30. At this point, we're going to draw a line down our inequality symbol. We are going to subtract our 0.75x from both sides. Because remember, our goal is to get y by itself. So we bring down our $1.25y is now less than, and I'm going to do what I did for the previous problem. I'm going to write my number with x first. So I'm going to have negative 0.75x plus 30. So from here, we need to divide both sides by $1.25. And I know this seems weird, a lot of decimals, but it's going to work out in the end here. So we bring down our y, we bring down our symbol, and then what I would do is I would take negative 0.75 and divide it by 1.25, and you will get the decimal 0.6, but because we're talking about a slope, we're going to leave it as a fraction. So we're going to have negative 3/5 x. 30 divided by 1.25 ends up being a nice whole number, 24. And now we are going to graph this. So we're going to start at 24 because that's our y-intercept. Our slope is negative 3/5. So we're going to start at 24 and go down 3. This graph is counting by twos. So if we go up to 24, it's going to be right here. And since both of them, x and y axes, are counting by twos, we can consider it, when we do the slope, count each block as 1. So we're going to go down 1, 2, 3 over 5 and plot our next point. Okay, continue to go down 1, 2, 3 over 5. 1, 2, 3 over 5, and then one more time, 1, 2, 3 over 5. So we have our line, our points. We need to decide if it's dotted or solid. So looking at our inequality, it is a dotted line. So we're going to have that line be dotted, and then the last part is to decide where we're shading. So again, you have the top part, which is up here. You have the bottom part, which is down there. So going back to our inequality, it says that y is less than. So less than means that we're going to shade below. So anything down here would be a possible combination. So remember, there's more than one answer to this problem. So the question asked how many combinations could he buy by spending less than $30. So you could go back and look at these ordered pairs, and you could say, you know, I'm going to pick this point right here, which is, oops, you didn't even see that, sorry. I'm going to pick this point right here, which is 10 hot dogs and 10 burgers. Or maybe you can say this point here, which is 0 hot dogs and 20 burgers. So there's more than one answer of combinations for him to buy for this barbecue. For the last problem, we have a local grocery store sells strawberries for $3 per pound and bananas for $1 per pound. If they have $10 to spend between strawberries and bananas, we're going to draw a graph to show what combinations of each they can buy and spend at most $10. Since we are not told X and Y, we're going to make X. X is going to be strawberries and Y is going to be bananas. So like we did in the other problems, we're going to create an inequality. So we know that strawberries are X and they're $3 per pound, but we don't know how many pounds there are, so we're going to start with 3X. Bananas are $1 per pound and bananas represented with Y. And you have at most $10 to spend. So that means that we can spend less than or equal to $10. We cannot exceed the $10 limit. So we are going to graph this, or sorry, not graph it. We're going to rearrange it so we can graph it. So we have Y is less than or equal to negative 3X plus 10. Or we could say 10 minus 3X. So we are going to start at 10. That's the y-intercept. And then we're going to use our slope, which is negative 3, and we're going to go down 3 over 1. So starting at 10, we're going to plot our point. Down 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So we have a couple points. So we need to decide if it is a dotted or a solid line. Since it has the line underneath, it's going to be solid. So we're going to connect, and I apologize that this line is not going to be very straight. So now we need to decide if we're going to shade on the top or on the bottom. So the question, or not the question, but the inequality says y is less than or equal to. So we are going to shade everything underneath the line. So remember, the question is, what combinations can you buy if you want to spend at most $10? And what you can do is you can look at any of those ordered pairs in the shaded area, and those are combinations that you can buy. So for example, you could buy, if we look at this point here, you could buy 2 pounds of strawberries and 0 pounds of bananas. You know, if we look at this point here, it's 1 pound of strawberries and 5 pounds of bananas. So any of those combinations would work out.